Alrighty, so in this video, I'm going to explain the importance of implicit by doing this derivative using implicit and then also using the long way, aka actually solving for y and saying why. It's important for us to use implicit rather than, let's say, solving this for y. Now, if I were to solve this using implicit differentiation, I'm going to get 2x minus 2y dy dx is equal to 0. 2x is equal to 2y dy dx, which means that dy dx is equal to 2x over 2y, which is the same thing as x over y. And I did a couple of steps. Easy peasy lemon squeezy. Now, I'm also going to show you the long way, and I'm going to see that, oh, it's essentially the same thing, and we'll see what that means. So, using the long way without using implicits, I actually want this to be in terms of y. So I'm going to move the 16 and the y so that I have this, which means that y is equal to plus or minus the square root of x squared minus 16. So I'm going to have two cases. I'm going to have the positive case, and then I'm going to have the negative case whenever I'm taking the derivative. So let's say that I'm taking the derivative of x squared minus 16, and then the derivative of negative x squared minus 16. And plot twist, both of them are going to be the same. If I take the derivative of this, I'm going to get dy dx is equal to 1 over 2 x squared minus 16, and then using good old chain, the derivative of x squared is 2x, which then gives me x over x squared minus 16. Now, notice how x squared minus 16 is the same thing as y from above. So I could replace this right here to be x over y. I'm going to do the same thing for my negative counterpart, where I have dy dx is equal to negative 1 half x squared minus 16 2x. And then I have, let's see, dy dx is equal to negative x over x squared minus 16, or the square root of x squared minus 16. Now, based off of this, we know that if I have negative y, that's going to be the same thing as x squared minus 16. So then if I were to replace the square root of x squared minus 16, I'm going to have negative x over negative y, which is the same thing as x over y. See how this right here is the same thing as this right here. Now, this one was just an easier example for me to show you why it's better to use implicit, just because I could take this and actually solve for y. For some of these that you'll see, though, you probably can't do that, so that's why implicit is important for us whenever we can't really do something like this right here.